Hello and welcome. Today we're diving into NEC 110.24a, Available Fault Current. That may sound intimidating, but stick with me, we're going to break it down step by step. Let's start with the basics. What is available fault current? Imagine electricity like water flowing through a pipe. When everything is working right, the water flows smoothly. But if the pipe bursts, or in electrical terms, a fault occurs, like a short circuit, then a huge rush of current can try to push through all at once. That sudden surge is called available fault current. In electrical terms, this is the maximum amount of current that could flow during a short circuit at a specific location. It's usually measured in amperes or amps for short. So why is this important? It's important because a big surge of a current can damage equipment, start fires, or even cause serious injury or death if things aren't properly rated to handle it. Now that we know what available fault current is, let's look at what NEC 110.24a actually says. The code states that service equipment and other than dwelling units shall be legibly marked in the field with the maximum available fault current. The field markings shall include the date the fault current calculation was performed and shall be of sufficient durability to withstand the environment involved. Let's break that down into plain English. Service equipment refers to the main electrical panels where power from the utility company comes into the building. Other than dwelling units means that this applies to commercial buildings, industrial sites, and any other place that isn't a single-family home. And the panel must be clearly marked with the maximum available fault current in amps, the date when the fault current was calculated, and a durable label that won't wear off over time. So this label tells electricians, inspectors, and maintenance workers how much current could potentially flow in a worst-case scenario. Now let's talk about the why behind this requirement. This rule was added to the NEC in 2011, and the main reason was safety. Before this rule, many electrical panels didn't have any information about fault current. That meant electricians working on those panels had no idea what kind of short circuit current they might be facing. This made it hard to choose the right equipment or figure out what kind of personal protective equipment or PPE they needed. In the event of a short circuit, if your panel isn't rated to handle that much current, it can literally explode or catch fire. The wrong circuit breaker could fail to trip, and protective gear might not be strong enough. So NEC 110.24a helps ensure the right circuit breakers are installed with proper interrupting ratings. Workers know how dangerous a panel could be, and facilities comply with arc, flash, and short circuit protection standards. You might be wondering, how do you figure out the available fault current? Well, that's a great question. Usually this is done by getting data from the utility company about the incoming voltage and the available fault current at the service point. Calculating how much of the fault current will actually reach your panel, taking into account the type and length of wires, transformers, and any resistances in the system. These calculations are typically done by engineers or qualified electricians using software or detailed manual methods. Once that number is calculated, a label is printed and installed on or near the panel. Let's look at an example to make this more real. Let's say you're working on a commercial building and you open up the main electrical panel. You see a label that reads, Available fault current 36,000 amps. Date calculated June 1st, 2025. That tells you that if a short circuit occurred at the panel, up to 36,000 amps could flow in an instant. Now let's say that the circuit breakers inside that panel are only rated for 20,000 amps. That's a problem. In an event of a fault, those breakers could fail catastrophically. This label is basically telling you that you need to operate the breakers or take safety precautions. So here are a few extra tips if you're just getting started in the electrical field. First is know your equipment ratings. Always check the fault current ratings of fuses, breakers, and panels before installation. Understand labeling. Get comfortable reading and interpreting field labels. They contain critical safety information. Keep records updated. If the electrical service changes, like a new transformer is installed, you need to recalculate and update that label. Ask questions, never guess. If you don't understand what the label means, ask a journeyman, inspector, or engineer. And finally, study the current code. The NEC is updated every 3 years. Make sure you're studying the latest edition for your state or jurisdiction. And that wraps up our breakdown of the NEC 110.24a, available fault current. To sum it all up, it's all about knowing how much short circuit current might hit your panel. It protects workers, equipment, and property. It is required in commercial and industrial service equipment. And it's a simple but powerful way to make electrical systems safer. Whether you're in school, on the job, or preparing for an exam, understanding fault current and the NEC 110.24a is a big step towards becoming smart, safe, and skilled electrician. Thanks for listening and stay safe out there.